the binomial theorem. Here in this binomial theorem, a binomial is said to be an algebraic expression with two variables in it. So here let us perform few binomials of various exponents or powers. So we are going to discuss about this topic, that is binomial theorem, in an advanced level. We are going to assume a binomial as x plus y, in which the first term is of x and the second term is of y, whose coefficients are of each 1. So x coefficient will be of 1 and y coefficient will be of 1. And now here a binomial any algebraic expression with two variables is known as a binomial. So now here we are going to observe few binomials of various powers. So here let us observe few binomials of various powers. Let the binomial be, so here we are going to assume the binomial as x plus y, whereas in which the first term is of x and the next term, that is the second term, is of y with coefficients as 1 and 1. Whereas in the first case, x plus y, the binomial with its exponent as 0. So here we know that it is equals to anything raised to the power of 0 will be of 1. Then in the next case, if x plus y, the same binomial, if it is raised to the power of 1, then that will be of x plus y whole to the power of 1 is equals to same x plus y itself. Then in the third case, x plus y whole raised to the power of 2. So this is according to the special product, that is a plus b whole square. It can be written as a square. So when we assume a as x and b as y, then its expanded form will be of a square, that is x square, plus 2ab as 2 into x into y, that is 2xy, plus b square as y square. So this is the expanded form of x plus y whole square. Then let us perform one more binomial with the third degree, that is x plus y whole to the power of 3 is equals to x cube plus 3x square y plus 3xy square plus y cube. So here when we observe, so these four conditions, that is fourth one as x plus y whole to the power of 3, here the exponent is of 3 and the number of terms in its expansion are of 1, 2, 3 and 4. So here in this case exponent is equals to 3 and number of terms in expansion of the binomial is equals to, there are 4 terms, 1, 2, 3 and 4. Then whereas in the previous conditions, that is third one, the exponent is of 2 and the number of terms are of 3. So here in this case the exponent is equals to 2 and number of terms in its expansion are of 3. And similarly in the second case, x plus y whole power 1, so here the exponent is of 1 and the number of terms in its expansion are of 2. So here similarly in the first case, so here the exponent is of 0 and the number of terms are of 1. So your exponent of the binomial is of 0, then the number of terms in the expansion are of 1. So here when we observe in all these 4 cases, so here the number of terms are 1 more than that of the exponent of the binomial, whereas in this case 1 plus 1 is of 2. So it is 1 more than the exponent of the binomial, whereas in the similarly in the third case exponent of the binomial is of 2, then the number of terms which we got are of 3, that is 1 more than that of the exponent of the binomial. Similarly in the case of the fourth, that is the exponent is of 3 of the binomial of x plus y whole to the power of 3, whereas the number of terms which we got are of 4. So here therefore the number of terms will be 1 greater than or 1 more than that of the exponent of the binomial. From this it is understood that by this it is clear that number 1, that is the number of terms in the expansion is 1 more than that of exponent of the binomial. Similarly, in the second case, in each expansion the exponent of first term is same as the exponent of the binomial. And the exponent of y, the second term, that is in the first term, is 0. In this case I said the exponent of the first term will be same as the exponent of the binomial. Say here in this expansion the first term is of x cube, the binomial's exponent is of also 3. So in this manner I say we will be getting the exponent of the first term is of 3 and similarly the exponent of the binomial is also of 3. And here the y term is missing, that is y to the power of it will be of 0. So always the y term in the first, the y exponent in the first term will be of always 0, and similarly and so on the successive terms will be of in x will be 1 decreased and whereas y will be 1 increased. So here in the third term, so here x is again decreased by 1, that is 2 minus 1 is of 1 here, and whereas here y to the power of 1 it is increased by means of 1, that is 1 plus 1 is of 2. Then now in the third case, that is the fourth case, that is the fourth term, so here again x exponent is decreased by means of 1 again, that is 1 minus 1 is of 0, that is x to the power of 0 is of 1, therefore x is missing here, and here y to the power of 2 is the third term, and as the fourth term it will be increased by means of 1, that is 2 plus 1 will be of 3, that is y to the power of 3. So in this manner we will be getting, so here subsequently in each term or in each successive term the exponent of x decreases by 1, whereas exponent of y increases by 1. So similarly, the exponent of x in the last term will be 0. So here, as per the condition which we got in the fourth condition, say x to the power of 0. So here x is missing, that will be of x to the power of 1 in the third term and x to the power of 0. That in the last term the exponent will be of 0 and the y exponent will be of equal to the exponent of the binomial. So last term will be of 0 and that of y is equal, that is the exponent of y will be equal to the exponent of the binomial. So in this manner, so we can frame when the exponent of the binomial is of n. So here similarly, or in other words, then we have the exponent is of x plus y whole to the power of. So if the exponent is of n, then the terms will be in this pattern. So here nc0 x to the power of n minus 0, that is the exponent is of n minus 0 into y to the power of 0 plus nc1 into x to the power of n minus 1 into y to the power of 1 plus nc2 into x to the power of n minus 2 into y to the power of 2 plus, so nc2 is the third term and nc1 is the second term. Then the fourth term will be 1 less, that is nc3 into x to the power of n minus 3 y to the power of 3 plus fifth term will be of nc4 into x to the power of n minus 4 into y to the power of 4, because the first term is of nc0, therefore the fifth term will be of nc4 into x to the power of n minus 4 y to the power of 4 plus similarly and so on. Then the last term will be of ncn into x to the power of n minus n into y to the power of n. So in this case, this is the expansion of the binomial, hence it will be called as the binomial theorem, whereas these values, that is nc0, nc1, nc2, nc3 similarly and so on up to ncn. So here nc1, nc2, nc3, nc4 dash dash, so here ncn are binomial coefficients. Then now, so let us write the general term of this binomial expansion. General term of this binomial is represented by means of t r plus 1, which is equals to since it is r plus 1, it will be of r plus 1th term. So we can write it as r plus 1th term. So here it can be given by means of NCR x to the power of n minus r into y to the power of r will be the general term of the binomial. Whereas here the values of NC1 coefficients, binomial coefficients values are of NC1, NC2, NC3, NC4 can be given by means of, so NC r is equals to n factorial by n minus r factorial into r factorial. So whereas n factorial is equals to 1 into 2 into 3 into 4 into 5 dash dash up to n.